Welcome to Chris Says, enlightening you about the new and exciting world of Juniper Networks, brought to you by Arrow ECS. Why are Juniper products different? Part 1. One of the main differences is in how Junos is architected. When Juniper first came up with the idea of Junos, most, if not all, network operating systems were then based upon monolithic code. Juniper looked at the limitation of this approach and instead decided to use the concept of a control plane. Inside the control plane are the modules that run the various processes, the routing process, the GUI process, and SNMP, for example. Underneath is the Linux kernel, which runs the modules, making sure they don't hog too much resource and restarting them if required. So compared to before with monolithic code, each process is a separate distinct item of code running on the kernel that then controls the resources and the processes. So for example, you can reboot the web GUI process without affecting the rest of the running processes. With monolithic code, sometimes your only recourse was to reboot the entire box. Then Juniper decided to run a data plane under the control plane. This gives Junos devices amazing stability and resiliency. The data plane is linked to the control plane by a throttled link and is the data plane that actually does the work of the Junos device. In the data plane, you have everything you need to process normal traffic. For example, there can be a read-only MAC address table, a forwarding table full of the next hops you need, and for the firewall there will be a firewall session table. This provides the data plane all the information it needs to handle typical traffic, and also by separating the control plane and data plane you get a lot of stability and flexibility. So say for example the data plane of a Junos device is being attacked with a volumetric attack. The control plane is then protected, and in theory you can monitor the device and respond to the attack. Likewise, if there's an attack or an issue on the control plane, the data plane should continue to pass traffic. Now the other advantage is by separating these you can do clever things regarding how you control Junos devices like switches, routers and firewalls. Let's look at switches. You have 4 switches, each with their own data plane, and they are linked with an Ethernet backbone. You only need one control plane to control these switches effectively, creating a large virtual single switch. This is what Juniper call a virtual chassis. A second switch would then run a backup copy of the control plane for an event of a failure of the primary. Each switch can also have diverse power. Because each switch runs its own data plane, we get the benefit of local switching. If traffic enters and leaves the same switch, then that data plane has all the information it needs to handle the packets. If it enters and leaves through different switches, then normally the entry switch does all the processing and the exit switch just fires it out of the network. This gives a very high speed throughput across the virtual chassis. Because of the modular nature of Junos, the separation of the control and data planes, and the stability and flexibility that gives, it means that Juniper devices are amongst the most rock solid and flexible network devices you can deploy. For more information, contact your Juniper partner. Or if you are a Juniper partner already, contact me, Chris.